but if you're like the type that you can go upstairs. There is a survey on your phone where you can judge these guys and how good they did. And there's a lot of swag in the expo hall. So head down to the expo hall. My team puts this event on, and I know that we have like pretty good swag at the Google booth at least. So I'm going to announce Joaquin and Matt. They're doing a talk on automating security operations.
Awesome, thank you so much. I think I've got this, yep. Awesome, well thank you for the great introduction. Really excited to be here, everyone. Excited to talk about how we are automating detection and response at GitLab. Okay, how does this work? Do I push the button?
Just hit the play button up there.
Oh, up here, oh.
Yeah.
The big green button. Okay, well let's start with introductions. So I am Matt Coons. A little bit about me, I'm passionate about automation and detection engineering. My current role is I'm a manager at GitLab in the incident response team, but I've come from a technical background and I've done a lot of detection engineering, automation, incident response, all of that fun stuff. I live in Pure, Michigan. Has anyone been to Michigan before? It's a great place to go and adventure and have fun outside. And when I'm not working, my 2 boys and my wife keep me busy going to lakes and taking our camper to fun places and stuff like that. I'll hand it over to Joaquin to introduce himself.
All right. Thanks, Matt. Hi, everyone. I'm Joaquin Fuentes. I'm the Director of Security Operations at GitLab. Passionate about hands-on security, so I like getting rid of the fear of the keyboard. Have multiple wins at DEF CON in CTF called Command and Control. Love photography, drones. I feel like I'm a forever student. I spent the last year traveling the world, but I live in Scottsdale, Arizona ultimately, and I am also a dad. So here is our agenda for the next roughly 30 minutes. We're going to tell you why we're here in the next slide. We're going to talk to you about a solution that framework that we sort of built to solve a problem that we've been experiencing at GitLab, and it's called Guard. Matt's going to talk to you about the details of the implementation. I'll talk to you a little bit about sponsorship if you like what you saw today and you're thinking about implementing it at your own organization. And then we're going to tell you a little bit about what we have in mind on our roadmap. So why are we here, right? GitLab, when we joined, faced what are probably common security operations challenges at any organization. You may have seen like alert fatigue. Your engineers are getting a lot of alerts that are similar. They might not have the best fidelity. You might have a lot of manual detection and have a lot of response engineering that isn't that mature. And then the value of the metrics and the alerts you're seeing might not be the best, right? Might not be that mature as well. So, I mean, that's a problem that you probably experience a lot throughout your career, depending on whatever team you go to. The engineers experience it, and then the leadership experiences it alike as well. So we wanted to talk to you about our journey in implementing Guard, which is sort of our detections as code framework, right? You hear about that a lot. You hear about like shifting left a lot. But we were excited enough about our journey and that we wanted to come share with you what we did in the event that you want to implement either Guard or something similar at your own organization. Transparency is one of our top values at GitLab. So we're lucky to have the support of our organization and to be able to come talk to you about even the problems that we encountered, right? The fact that, I said, hey, we had a lot of manual detection and low fidelity alerts, and how did we get to solve this problem quickly? Someone asked a little bit earlier, like, didn't you just use a SOAR, right? Like, that's probably the question, right? Like, why not just use a SOAR and that solves all your problems? But as we talk through the implementation, I think maybe it'll hit home for you and you'll understand that, you can't just buy a tool and you can't just have smart engineers. At the end of the day, what is it that gets you from point A to point B the fastest? And for us, that was something like building a framework around it. So that being said, back to Matt, and Matt's going to get into the details of Guard.
Okay, thank you, Joaquin. So introducing Guard. So what is GUARD? GUARD stands for GitLab Universal Automated Response and Detection. Our automated alerting and detection engineering framework. One thing I'll say is we're not selling something today, so this is not like an add-on to GitLab, like, hey, pay extra money and you get GUARD. We just wanted to highlight our story and how we did this. As Joaquin mentioned, transparency is one of our values. So we're blogging and open sourcing what we can as we go for the good of the community and for other folks who may be on a similar journey or want to do something similar. Talking about some of the highlights, and we'll talk about this a little bit further, but talking about some of the highlights of GUARD, one of the things that was really important for us is that alerts were in a standard format. Have you ever seen alerts that don't come in a standard format? They look different based on where they come from, and maybe some of them have a lot of context, some of them don't have a lot of context. That was something we wanted to try to fix with GUARD. And so we wanted to collect rich metrics, identify valuable trends, things like what are our true positive, false positive ratios, information like that. We also wanted to commit our detections as code. So we didn't want our security engineers to be going into our SIM and editing the rules directly in the SIM because that could introduce some element of error. We wanted to use GitLab as our single source of truth and use the CI pipeline features built into it to be able to do that. No surprise we wanted to use GitLab, right, as we work for GitLab, and it really worked out well for us. We also wanted to collect metrics along the way. So identifying trends like, as I said, what are our true positive, false positive ratios? What detections need to be tuned? Information like that is really important for us as we went along this journey. And we also wanted our detection and alerting pipeline to be SIM agnostic. We really love our SIM vendor, but we wanted to ensure that we future-proofed our work and we weren't locked into one ecosystem or have all of our eggs in one basket. We wanted this to be more than just a SIM or more than just a SOAR platform, kind of be a framework that's agnostic. Okay, so let's talk a little bit about the two main components that go into GUARD. And so these are complementary workflows with the feedback loop in between. So starting at the top, you have detection engineering. So you start with the new detection idea, right? Maybe you ran a hunt, maybe there was some white paper you read or some blog post, something on Twitter or X as it's called now, whatever. You start with a new detection. That idea goes into a detection validation pipeline. So we have this CI pipeline that validates our detection code. It does things like make sure that the syntax is correct and it's not too many false positives, stuff like that. All automated. And then from there, we actually deploy the detection into our SIM, which is Devo in our situation. And then we collect metrics on that as well. So we didn't want to just automate the entire process. We wanted to be able to answer questions like, what MITRE attack techniques do we have coverage for? Are we really heavy in one log source? Maybe we have 50 detections for one log source, but only 2 for another log source. Answer those questions. And you'll notice that there's kind of an arrow that feeds back around this feedback loop to the detection response flow at the bottom, which is the security engineers doing their work day in and day out, right? So you have a triggered alert, it comes in, we enrich that with our SOAR platform. So we add contextual information and details about what the security engineer really needs to know as they're handling this alert, and then it's sent to Slack. We think that for our team, Slack triage works really well. So these come into Slack, our team use as their place of initial triage. And we have some really cool, some kind of automations around that I'll show as well. And then from there, we have metrics and feedback that is both collected from the alerts, metadata about the alerts, but also feedback that the security engineers can add themselves as well. And then there's this kind of symbiotic flow between the two. Okay, so let's talk about some requirements. What were some things that were table stakes for us that we really needed to solve and we wanted to focus on when we developed GUARD? As I already said, we wanted a SIM agnostic solution. We love Devo. It's a great SIM. It's a great tool and it's a great part of our security stack. But we wanted GitLab to be our single source of truth for our detection code. We didn't want to necessarily store detection code only in the query format. We wanted to have a structured format that we stored our detection code in. And we'll talk about that a little bit more and what that looks like. We also wanted our alerting and detections to be standardized. So we wanted, all of our alerts to have one format. When our security engineers come on shift, we want them to know what to expect, what an alert should look like, and how they should handle the alert. And then we want our detections to be in a standard format and SIM agnostic as well. Okay, we have this great idea at GitLab called the boring solution. So this concept of the boring solution is that it's not overly complex just to be overly complex. If there's a solution that's going to work well for the team and it's boring, that's okay. And so we really focused on the boring solutions as we were coming up with this framework, which might sound a little funny, right? Because we're talking about this framework that we built, but we wanted it to be boring and work well for our team. So we wanted to have a seamless alert triage and detection process. When our security engineers are triaging alerts, when they're looking at detections, we want them to know what to expect and for it to be seamless and not intrusive, not 15 buttons that they have to click to do a simple action. We also wanted fewer clicks on alert triage. So I have been in situations before. I've worked as an individual contributor where I have to click 15 different buttons and categorize all of these different things for a simple alert, right? And it just adds a bunch of overhead that in some situations maybe isn't necessary. So we wanted to make it straightforward, but also, collect rich metrics for our team as well, which was important. We also needed an easy conversion to an incident. So let's say someone's triaging an alert. It's something that looks really bad. They need to have an easy way to convert that into an incident to start handling it as an incident and following the incident response process, right? Or a bug report. Maybe this is a reoccurring problem that keeps on happening. They need to be able to submit a bug report so someone can go tune that detection. Less redundancy, copying and pasting, making things less redundant. We didn't want to introduce a lot of complexity. And then I already mentioned metrics, but we didn't want to just collect metrics to collect metrics. We wanted to collect the actionable metrics. What metrics tell a story? Okay, so now that we've talked a little bit about the requirements and some of the high-level overview, let's talk about how we actually implemented this. Okay, so some of the core components that are involved in Guard are GitLab. It's our single source of truth for all of our detection code, where our detections live. We have a CI/CD pipeline in GitLab, and that's what handles from committing a detection as code and then pushing it to our SIM platform. Our SIM is Devo. We love Devo. It works really great for us. That's where all of the detections run, and we have alerts that are triggered and stuff like that. Our SOAR is Tines. That's kind of the platform that helps us connect these different components together. And then we do our alerting in Slack. So when a security alert triggers, it comes in through Slack in a standard format, and then we triage them there. I'm not going to talk through the detailed diagram here, but the idea is that you understand there's a number of components involved. As Joaquin said, this isn't just a SOAR. That's a component of it. But there's all of these different components that make up this framework that we've developed. Okay. Well, let's talk a little bit about detection engineering. So as I already mentioned, GitLab is our single source of truth for all of our detections, and we wanted to store our detections in a SIM-agnostic format. We actually use JSON. So we store our detections in a JSON format. Now you might ask, well, how does that work if my SIM doesn't use JSON for the query language? We do have a JSON element that is the query in the correct query format. Everything is in JSON format. We map it to MITRE attack. So information like, what MITRE attack techniques is this detection related to? Then we can go and query that information and pull it back and get metrics on it. We also wanted to reduce the error by manually editing detections in a SIM. Has anyone ever made an error by editing a detection manually in a SIM and clicking a button they didn't mean to? I know I have. So we wanted to make sure that our team members didn't go in, edit detections directly, and then there wasn't an auditing trail of that. So by abstracting their actions and having them do it through GitLab, we have auditability, we have changes. Whenever they submit a change, we can see what the change was and what changed, we can revert it easily. And we have this automation that pushes the changes to our SIM using GitLab CI/CD. And so the screenshot here, and if it's a little small on the back, apologies, but the screenshot here is actually the change request template that someone uses when they want to change and add or delete a detection. So information like, what's the title? What's the MITRE attack mapping? What is the reason for you doing this? It's stored, and they, our team members add this information in, and when they click submit, it's recorded as part of our single source of truth in GitLab. So we have all of this information about our different detections and what's changing over time, which is really valuable for us, so we can have that audit trail. Okay. So one of the coolest parts of this whole thing, in my mind, is our CI/CD validation pipeline. If you've ever used GitLab CI, it's actually really straightforward to use and works really well. And so we use this to validate a number of different things. First off, we ensure that the MR, this is really just the merge request, the change request I was showing you earlier. We want to ensure that the fields are filled out correctly. We want to make sure that there aren't missing fields or there isn't missing information. We want to make sure the syntax is correct and stuff like that. It actually validates the detection syntax via the Devo API. So when you click submit, it actually goes out, uses the API to check the query, make sure it's valid, and then it also verifies that the detection is not false positive heavy. I've been in a situation before where I've submitted a detection that had way too many false positives, and all of a sudden detections start popping, in your alert channel. I know that's not a good feeling, so this is kind of that first pass in making sure that doesn't happen. And then it actually goes and makes the change via the Devo API, and then verifies the change was successful. That last piece is really important, and that was actually something we added in. We didn't add that in at the beginning. That was something we added in as we iterated and made this better, because we wanted to make sure, that hey, when we made the API call, it was successful, and the change was there. The new detection was there. The cool thing is this is all automated, right? This all happens whenever you submit a new detection. This pipeline runs and does all of these things automatically. Okay, so for alerting, we use Slack. This is one of my other favorite parts, that we use Slack for alerting. We deliver our alerts via via Tines to Slack. So Tines is the intermediary there. It sends them into Slack, and we deduplicate alerts through Tines. And so the great thing is, by sending them through Tines, by developing this framework, we have a standard alert format. We actually have like a nice interactive workflow that they interact with when they are working on alerts. We also wanted there to be an effortless closure process. I know I've been in situations before where closing an alert is many buttons and many clicks and many things that maybe aren't necessarily relevant to that alert. We wanted to make it seamless, the boring solution, if you will, but also collect useful metrics. We actually have an emoji-based kind of workflow, so we use emojis, which is super freaking cool, and we can convert it to an incident or submit a bug, and that's kind of our process, how we close an alert. We also are collecting valuable metrics from closing alerts and just interacting with alerts in general. We collect things like true positive and false positive ratios, which I think most mature organizations do. But one of the cool things that we were doing is we're collecting sentiment analysis. So when someone is working on an alert, they can give a thumbs up or they can give a thumbs down. They can say, I love this alert, this is really valuable, or this is a terrible alert and I hate it. I see some people laughing because maybe they've been in that situation before. So it's great, and we can collect those metrics and look back and then identify. Okay, so let's talk a little bit about the workflow and what it looks like. So here on the left side, the left side, you have the initial alert, and this is what it looks like when it comes in. I've got some fields that are redacted here, so if you see some black bars, that's why. But you have, the alert title, who it's related to, all of that relevant information, and there's two important buttons here. There's an acknowledge alert and a close alert. Acknowledge alert means I'm going to take this alert and I'm going to work it. I'm going to be the DRI, the directly responsible individual, to handle this alert. And then when you're done with it, you can click on close alert. The other thing is you can assign it to someone else. So maybe if you're delegating an alert out, maybe you don't have, you can't do 15 alerts at once, right? I'm handling an alert. I need someone else to help me with one. I can delegate it to one of my peers. So once you click the acknowledge alert button, a thread is opened automatically by Tines, and then it adds enrichment information into the Slack thread. So it'll say, hey, I found some context that might be useful. And it'll return information like, how many times did this alert happen for this user or this host? It might be valuable as you're working on this alert, and I'm kind of trying to identify, is this really something to be concerned about? Do I need to, do I need to ping my manager and my director and get everyone on a war room bridge to handle this, or is this not that big of a deal? So after you're done with the alert triage and handling the alert, there's this really cool alert closure process. So once you click close alert on the left screen here, the alert closure form pops up in the thread. And so you can select the categorization of the alert, and then the sentiment analysis. I think is super cool, if you like it or you don't. And then if you need to convert it to an incident or report a bug. And then lastly, there's a mandatory closing summary that's really important, because we have to collect some information about the engineer and like kind of the steps that they took to close the alert, right? And so the great thing is, I think that this workflow right here is a lot less work than other alerts I've dealt with at other organizations, right? But it still collects very valuable metrics and useful information. So we tried to make it the boring solution work well for our team members, and then also collect that useful information that we need. Okay, so lastly, it was really important for us to collect metrics, right? DynamoDB, we have a DynamoDB metrics database that is collecting all of these metrics from our alerts and our detections as we handle them. So this alert metadata is sent to the DynamoDB database, and it's sent there for analysis. And it really helps us answer really important questions, like, what are my true positive, false positive ratios? What are my best alerts? What are my worst alerts? Does everyone really hate this one alert? And they keep on clicking, the thumbs down, and they really hate it. Maybe I need to work on that one. And then which detections trigger the most, or maybe the least? And MITRE attack technique mapping and stuff like that. So those are all really useful and pieces of information. There's more, but those are some high-level metrics that we can help answer with our metrics database. Great, so this is all really good, but one of the things that's really important and necessary for something like Guard to be successful is for there to be executive sponsorship. So I'm going to hand it over to Joaquin to talk a little bit about that.
All right. Thanks, Matt. If you like what you heard, you're a practitioner or you're a leader, and you're passionate about doing something like this on your team, right? Like, we can't just have good tools, and we can't just have good engineers and then hope that we buy all those things and have the right people and magically it all comes together. I think this is a problem we encountered and we were trying to solve ourselves. I've seen at other organizations where you have all these things and somehow the magic sauce doesn't work, right? Like the automation doesn't occur. So I think the framework was important here, but once you have this vision and you have the right things in place, you need that executive sponsorship, right? You've got to be able to get the budget to buy the tools, and you've also got to convince people to motivate them that you've got to implement a framework like this, and we'd like to do it in the next year, right? So I just want to share with you very briefly, what does it take to get that executive buy-in? You really got to tell a story, right? Here are the core challenges that we have. I'm seeing low fidelity alerts. We're doing manual work for X percentage of the work that we do. It's very inefficient, right? Into things manually. I also don't like waking up in the middle of the night, right? As a leader, that kind of thing. And here's our MITRE attack mapping. I also took an opportunity to sneak in a quote from Training Day, one of my favorite movies. Denzel Washington says in that movie, it's not about what you know, it's what you can prove, right? So you can't just go to your executive team with a vision and say, hey, here's the thing I want to build, give me some money, right? You have to prove it, so you've got to use real world examples. Here's what we're seeing on our team. We had our team go back and do an analysis for the past year. For our most severe critical incidents, what have we seen? And we were able to give metrics on here's how costly it was, real dollars. Here's how costly it was, indirect dollars. That's time that people had to spend, development cycles, right? Engineer hours, any other teams you needed to reach out to. And then you have to have that vision, like automation, right? I want to automate things. It's going to pay dividends later. This is what the numbers look like. I think it's actually going to have this ROI for us, right? One thing we may forget as leaders, though, is you have to have practitioner advocates. So if like you're the one that came up with the vision, or you're like, I'm going to go do that at my organization. We've been stumbling on manual stuff for years, and it's, you know, kind of just feels like business as usual. You got to get a couple of really good practitioners to buy in with you on this idea, on this vision, to the point where they're willing to go get you the metrics, because that's really the hard part, right? Like, how do you share with your executive team metrics that are meaningful, and you can't just grab the data that's usually available. The hard part is they've got to go put in labels, or put in signals in different areas so that you can get the metrics that are really meaningful for you. So that's it for sponsorship. What are we thinking about in terms of the future? Like, we started on this journey. We built a framework around it. We're going to open source some of the things. We're going to blog about it for transparency and communication. But this is not like the end-all solution for us, right? Like, it's an evergreen framework. Here's some things that we're thinking about as we mature Guard. The first is like threat intelligence mapping. Like, is it covering the right TTPs? Are we other organizations that are in a similar, not just the industry, but that are providing similar solutions to us? And are we preventing are we detecting the right things? Are we responding the right way? Do we have that built into this automation framework? So is it covering the right TTPs there? And then also, in terms of like MITRE attack, we want to do a gap analysis and say, hey, let's expand Guard to cover more of the matrix, but not just covering more of the matrix because we want to be able to say, hey, we have 100% coverage. 100% coverage doesn't make sense, right? Like, we don't use Microsoft Windows, so we're not interested in covering anything that is specific to Active Directory or things, related to that. AI, right? We're going to become obsolete if we don't lean heavily into AI. And so we're thinking about how we lean heavily into making sure that Guard validates our detection syntax. Like, it's kind of like a peer review, right, of our detection capabilities as it happens. Our syntax is correct, but we want to make sure that it's valid all the way around. Covering the right things in terms of our what we're seeing in the industry, what people are getting hacked by that do operate a similar business, and then is it stack specific for us? Shifting left, right? Like, it's a common term you hear, but what does it mean for Guard? What does it mean for us? It really has to do with things like automatic isolation, right? Like, something that a lot of organizations are scared of, but if you implement a boring solution, then it should be pretty straightforward. Like, hey, we know with a lot of confidence that like this behavior is behavior that is experienced whenever a token gets exposed, right? And the worst thing that could happen, as long as it's not like a service account type token, is that we temporarily disabled or banned a token, and we've got to create a new token on the fly, right? If that happens. And then we have something that Matt covered briefly, but it's like user attestation module. So instead of your engineers or your responders responding to everything, an alert goes off, a lot of those we can send directly to the user. Hey, there's anomalous activity. Was this you? And then they get that through Slack. They can respond to it. If they don't, we have other automation that will still do, possibly containment or alert us instead. But we want the users to be empowered to say, hey, yeah, like, I'm working on this change. It's me. I'll put in an issue number, and life goes on. And then lastly, automating transparent communications. So as these automated activities, response and detection occur, then the user gets that feedback right away. Hey, a token was revoked because it was exposed, that sort of thing, right? Wrapping up, if you want more details about what you heard today, if you like what you heard today, we're going to be releasing multi-part series blog about Guard. We're going to be open sourcing the parts of the framework that we can so that you can implement something like this, or just get some ideas from it. And then last of all, if you like what you heard, again, there's our LinkedIn and then our Twitter handles. If you like that sort of thing, we'd be happy to hear from you and network with you. That's it for our presentation. We have a few minutes for questions if there are any.
Hi, thank you. Great presentation. Could you talk about some of the challenges that you guys experience, either for executives or from a technology perspective, and how you guys overcome those challenges?
Yeah, I guess I could talk about the executive part. Yeah.
Yeah.
I think one of the most difficult things, challenges from the executive level was we actually used to use a different SIM before Devo, and the API just wasn't robust enough to meet our needs. The performance wasn't exactly there, right? And so that was the biggest challenge. I went from a certain budget to a much larger budget, right? And so, I had to convince the organization that in order to achieve this vision of automation, in order to automate all the things and have this like ecosystem that worked, I had to have the right tools in place. And that budget wasn't already there. I joined GitLab a year and a half ago, came from Zell. And what I did to overcome that was basically sort of what I mentioned briefly on one slide, but to touch on it a little bit more, is I had to tell, hey, here's what I'm seeing. I'm seeing, and I actually had our team go through. I had these practitioner advocates that I was talking about. These engineers went through, and really, I should mention, like, kudos to them. They did all the hard work, right? Like, my part was easier. I had, some of the vision. Matt shared it, and our other leaders on the team. And what we ended up doing was going through, literally, we did a deep dive, basically case study into all of our most severe and critical incidents. And we said, here's the reasons why we weren't more successful in reducing the time to resolution. Here's actually, like, we had to be very transparent and expose ourselves and say, look, we took a look at it and the team actually wasn't able to complete this investigation. And that's like a real world thing, right? Like, I'm assuming everybody in this room at some point in time did some type of investigation, or their team did, and you're like, wait, I can't answer some of these questions. And that's really like the selling point for the executive team, right? Like, here's the questions that will continue to be left unanswered. Here's the questions that in the event of a catastrophic breach, we won't be able to answer because we don't have a solution like this in place. And I think that was the biggest selling point. I don't know if you...
Yeah, I was going to say on the technical side, one of the main components that, I think is a little bit, it wasn't super hard, but it took us, we had to be intentional about it, was going back and fixing the tech debt. A lot of times there's like that feeling of like, oh, I want to build, automate, make new things. It's awesome, but then like some of the challenges I was talking about with like alerting, we had alerting in all these different formats. You have to go back and fix the tech debt of figuring out like where those come from, how, like what are the different sources, like consolidating them into a single pipeline and then fixing that pipeline, right? So, some of like the first couple iterations of this wasn't really so glamorous. It wasn't like, oh my goodness, I'm building this amazing thing at the beginning. It was like fixing the stuff that was broken. And then that sets the groundwork to make things better. So, I think just getting your mindset in the place of like, there's going to be some tech that you have to fix first before you can make this really cool like framework. Yeah.
Hi, great presentation. I had a quick question for Guard and a lot of the technologies you guys use. I was just curious if for your SOC incident responders, do they primarily for triage and investigation, getting like alerted of all these things, is that only through Slack, or do they use any other, like do they go through the SIM that you guys use as well, or any other avenues, or is it solely through Slack?
Yeah, that's a great question. So Slack is, so like right now, our volume of alerts isn't so like crazy that we just like have like a stream of alerts that you just can never keep up with. So thankfully, we are able to do it through Slack. But the thing I didn't really talk about a ton is that there is a bidirectional communication between Slack and our SIM, or Devo or SIM. So like when you acknowledge an alert or work an alert or close an alert in Slack, it calls the API and then closes the alert in Devo as well. So it doesn't just like leave all these open alerts, you know. And so our security engineers, you know, can and do go into Devo and then like add context there if they want. But you know, like if they do everything through Slack and click the right buttons and then click submit, it'll like record all that information back in our SIM. So that's all there, you know, stored, you know, for our retention policy. So we have all of that information if we ever need to go back and look at it. So we wanted to kind of like reduce the number of places you had to go, right, for alert triage. If it's like something that might be a true positive, you're going to log into your SIM and start investigating anyway, of course. But for like those initial steps, we wanted it to be kind of a single place that they could go. But great question, thank you. Any other questions? Yeah.
Hi, thank you. So thank you for the presentation. I have a very simple question, but it's just like you mentioned about SIM agnostic detection as code and single source of truth, but you showed some like screenshots about metadata that you collected, such as, you know, what does this map to MITRE? I'm wondering what you do with the actual alert logic, because you mentioned it is SIM agnostic. I'm very curious, do you rely on SIM specific search syntax to document your search logic, detection logic, or do you use natural language? And how does that fit into your JSON standardizations? Thank you.
Yeah, thank you. That's a great question. So on our roadmap, we are you know, converting, or one of the things we're going to do is convert our detection logic into a fully SIM agnostic format. Right now, the way it works is there is a JSON element that contains the link query. It's, you know, for Devo, right, in that format. But then there's, you know, the rest of the information about like the description and all of that are in other elements outside of that specific detection query. So the detection query itself is the only component that's SIM specific. But one of our, you know, our future iteration steps is to move that to even be SIM agnostic. So let's say, you know, down the road, you know, we needed to change SIM, or maybe we had a different environment that didn't support the SIM, we had to do something different. It would be, you know, very, very quick to convert to that other format. So it's a little bit of both. Thank you.
I have one myself. What type of tech management debt do you have with the management of your CI/CD pipeline?
Tech management debt of our CI/CD pipeline? That's a great question. I mean, so like we built the CI/CD pipeline from scratch as part of this. So I wouldn't say like for this specifically, we really have any tech debt with how we built the pipeline. And thankfully we have a couple of staff engineers who are really knowledgeable about how to build a pipeline like this, and, you know, and set it up in a way that makes sense. And they did a really good job of documenting like kind of everything that the pipeline does. I mean, the reason I love, you know, using a CI pipeline is because everything is, you know, in a VM that's spun up and happens on the fly, right? So I don't think it's a problem for us now, but I think that's definitely something we need to, you know, keep an eye on, of course. Thank you.
I think the good news is like we didn't have tech debt because we didn't have that pipeline already.
Right, yeah.
And that was also the bad news. Yeah.
Yeah.
Thank you for the presentation. I wanted to ask if you had any metrics that you'd be willing to share that you find valuable or that are, you know, resonate with your leadership.
Yeah, so on the metric side, I think one of the most important, you know, metric is just your true positive, false positive ratios. And one thing that we actually did is we split out false positive into benign and then false positive. And that was really important for us because we didn't want to say, okay, you know, this detection is like, you know, or this detection is doing what it's supposed to, but it's, you know, it's not really a false positive, right? It's detecting what it's supposed to, but it's benign activity. Like the person was authorized to do that activity, right? The detection itself wasn't malfunctioning. It wasn't a string mismatch, or it wasn't like something like that, right? So we broke out our false positives into benign and then, you know, true false positives and then true positives. And a good idea of, you know, just what our value is. So that combined with kind of the heat mapping of what detections trigger the most really gives us a good idea where we need to go tune. And that's something that, like, you know, it's an iterative process. You're never done tuning. You're never done fixing your detections. It's going to continue on forever. But one thing that we do and we're developing is like a kind of like a weekly summary that's posted into Slack, right? So like, hey, here's like in the last week, these are the top detections that triggered the most. These are the ones that were the most false positive heavy. Maybe these are the ones that were the best. And so like that type of information that just like is pulled right from our metrics database, and then that gives our team members like a place to start, right? So, you know, instead of hearing from your team members like, oh, I'm just always dealing with all of these false positives, it's really annoying, like now they have actionable information to go fix it.
And some of the metrics will show up in our blog series.
Yeah,
as
yeah.
Well,
Well,
so,
we'll be
yeah.
diving into that further, yeah. I think we've got one back there. Thanks for all the questions, I appreciate it.
Yeah.
Thank you for the presentation. My question is regarding the flow chart you were showing, where you're pushing the detection, you're doing some validation if you're getting false positives. Do you put thresholds to the results, or how do you measure the false positives before the detection is live in that pipeline?
Yeah, great question. So it actually will fail the pipeline if there's too many false positives. So what it does is it actually runs the detection query in Devo, and then I don't remember the specific threshold off the top of my head, but there is a threshold that's set in the pipeline. And so when it returns back the number of hits that it found in the last X number of days. And if the threshold is over that, it'll fail the pipeline. And so the detection actually doesn't get pushed to the SIM, and then, you know, one of our engineers is like, well, why did the pipeline fail? You know, and then you click on the pipeline, look at the details, and it says, you know, too many false positives. And then you have to go back and fix it. So that's a great way for us to just ensure that maybe someone isn't like, you know, like, oh my goodness, under the gun, I need to put something in right now. You know, this is a, you know, really critical detection, add something, and then just blow up the, you know, the alert queue. We don't necessarily want that to happen. So that detection check really helps us with that. Thank you.
I think in a perfect world, like the number of high because the alert isn't necessarily tuned properly or defined properly. Maybe in an edge case, like it's too high because something's actually there, right?
Right,
so
right.
Either way, like there's a call to action because the pipeline failed.
Yeah.
Do you have any strategies for how close to the source you do your tuning and detections, and how that impacts a detection framework like GARD?
How close to the source? So you mean like the source of like the log data coming in?
Yeah, so I'm thinking about, are you handling all your detection engineering in your SIM? Or are you, for instance, in your ADRs or something, also putting in tuning there? And how does that connect to GARD and your strategy?
Yeah, great question. So I would say the vast majority of our detection tuning is right in our SIM. Most of our log data is right in our SIM. Our EDR is actually a good use case. So we do have, you know, some detections in our EDR, and those detections, we also have an MR pipeline that we record those through. But the goal of GARD is that all of our detections are handled through that, right? Because then it's really easy to go and look at, you know, your change requests, or keep on calling them MRs. You go back and look at all of your MRs, and you can see in one place all of the changes that you made. Actually, to add on that, another thing that we're working on is like a global, you know, kind of exclusion list, right? So it's very clear, you know, like this exclusion is for this detection, and it was added by this, you know, on this date by this person type deal. So we have that like level of like transparency across the board for everything. So that's something that's coming with GARD as well.
All right, last question coming up.
Are you using the same GitLab instance that the rest of us can use? And how do you secure the traffic between GitLab and the SIM?
Yeah, so we are using, you know, GitLab.com, right? So GitLab SaaS. And so, you know, we're using the built-in security features to ensure that, you know, we're not like, you know, leaking, you know, credentials and stuff like that outside. Thankfully, GitLab has a lot of great, you know, kind of features that allow us to secure our pipelines and all of that. One thing we also do is, you know, GitLab is a little different than other organizations where we don't have faith in like, you know, like we're going to keep everything, you know, we're going to keep as much information from everyone as we can. So like, for instance, we have a tech stack that's public. So you can go look up our tech stack and see what applications and security applications we use. Anyone can look at that. You don't have to be authenticated, right? So like, you know, so we have a little bit more of an open model when it comes to information like that. We still do keep our detection logic internal, right? But we are able to put guardrails in place in GitLab to only allow, the appropriate personnel to see it. So, great question.
We're at time. Thank you very
Awesome.
much.
Thank you so much.
Thanks, everyone.
Yeah.